Hello, this is Dan Vlamis. Welcome to our Analytics and Data Oracle User Community TechCast. We have a fantastic lineup here with Karl Rexer and Tim Vlamis, yes, my brother. We're going to talk about Karl's findings in the data science review. But before we get into that, let me go ahead and go through a little bit of Analytics and Data Oracle Community housekeeping. Carrie, if you go to the next slide. This is in a series of TechCasts. We put these on about every 2 weeks or so, and you'll find a slew of them all the way going back to 2019 on our website at andouc.org/techcasts. Carrie, if you could just see for this click to see live TechCast page works. Let's try that. We have some great TechCasts coming up where we're going to be talking about our favorite features of OAC. That's coming up on in August, if that works, and we can see the screen. You can see that coming up in early August. I'll be joined by Wayne Van Sluis and also members from the Oracle product management team about that. But you can see all those on there, and we would also encourage you to submit your own ideas for a TechCast. This is a user community, so we like to hear what you would like to talk about and what you think others would like to listen to. So join us for future TechCasts on all sorts of topics coming up. Go ahead, next slide. We also have merchandise. Look at our store and you can see color changing mugs and all sorts of great stuff to help support the Analytics and Data Oracle user community. Go ahead, next slide. So we are a community. We like to have people try and join us in our conversations. You can see the various URLs for our website. That hosts most of what we have at andouc.org. We also have a shortcut to join our Slack community. We'll have all sorts of stuff on there talking about various technical topics, upcoming TechCasts, that type of thing. The YouTube channel also has all of our previous TechCasts are hosted up there. If you click on the little YouTube logo off of our homepage at andouc.org, you'll go directly there, or you can use that bit.ly URL. We're also on Twitter, Facebook, LinkedIn. Also, the Spatial and Graph SIG has their own separate section on LinkedIn. So join us as a community and join in the discussion here as well. We encourage all of you to join with us. Go ahead, next slide. I'll also give a shout out to ask you to save the date for our Analytics and Data Summit 2024. We did this kind of reboot after COVID. Last March of 2023 went great. We're doing it again. More in detail is on our website on andouc.org's A&D Summit 2024. We're at the Oracle headquarters area in Redwood Shores. And if you're into this type of stuff, talking about data science stuff, especially on an Oracle platform, we'll be talking all about that at the upcoming Analytics and Data Summit 2024. So put those dates on your calendar and there's more information. You can also register your interest for attending the conference, and we'll have more details as it comes out. As well, we do have the call for speakers open, and you could submit your ideas and come attend and present to people that are especially passionate about analytics and data. Okay, next slide. With that, let me go ahead and start transitioning. I'll ask you to put any questions you may have into the Q&A widget at the bottom of the screen. And you can say hello in the chat, where you're from, that type of thing. But put any questions, especially that you want Tim and Karl to address on this. With that, I'll introduce Karl. Rexer is actually a former board member of the Analytics and Data Oracle user community, now the president of Rexer Analytics. We're thrilled to have him back presenting his data science survey results. And my brother Tim is going to kind of serve as the, how did you guys come across these results type of the moderator?
Well, commentator.
Go ahead.
We'll take it from here. So No, we're really honored to have Karl Rexer with us. Karl, you want to kick us off and kind of give us a little background on how long you've been doing this survey and kind of what some of the more recent results are?
Absolutely. And just want to double check that everyone can hear me.
Yeah, we hear you great.
Just double checking. All right, so yeah, if we can advance the slide, you can see that we've been doing this survey for a long time, almost as long as I was a board member. So we started in 2007, and we started off every year, and then we cut back to every 2 or 3 years. And so this survey was our 10th in the series. And that's really nice because we end up getting trending data. So we can really ask some of the questions, get asked every single survey. And then each survey also tries to focus in on particular topics. So this time we tried to focus a bit in on deployment, and in addition to our other things, we also included some stuff on deep learning that certainly wasn't a topic back in 2007. So it's been evolving over the years. This year, it was also a little bit different, and we had a partner, Eric Siegel, who's founder of the PAW Data Science Conference Series, Machine Learning Week, they call it now, and the executive editor of Machine Learning Times. He's written a couple books, and he has another one coming out in February that focuses on deployment. And so he was doing a part-time visiting professorship at Darden School of Business. And so part of his participation in the survey stuff and giving us questions on deployment and some of these other topics that are near and dear to his heart was great, because it gave us other topics that were good for us to ask about, and then helping us in interpreting those types of results and putting those in the larger context that he is seeing. I think Tim's going to have some comments about some of that. He and I were talking about some of these deployment results yesterday as well. So we'll get Tim's perspective a little bit later on some of those topics too. So if you can go advance the slide. We can start off by saying, well, hey, okay, we've been doing these since 2007. This particular one had 32 questions. Sometimes we've had over 1,000 participants since COVID, and since just the inundation of people being asked to participate in so many surveys. It's not just our survey, but across all survey avenues and projects. It's difficult to find participants these days. And so our number of respondents is slightly lower than it has been in some earlier years, but we still had over 300 participants from 49 countries participating in the survey this year. So it's a nice, good size sample. And we collected our data from January to April of this year. We have a mix of people from different sorts of places. And historically, we've tried to break these down into the consultants, the people who are working in corporate settings, vendors, NGOs and government and academic people. And then for some of the analyses, we will focus on particular groups. Particularly, we've often taken the vendors out when we're asking about, like, hey, what analytic tools are you using? It doesn't seem fair to include, all the people from IBM saying, hey, I use IBM's tool. So we take the vendors out when we do those sorts of analyses. But you'll see those broken out in a few minutes. If you can advance the slide. Part of the reason we started doing these surveys in the first place is because when we were at conferences, we ended up having these conversations in the hallway saying, hey, how big is your data set? Are you seeing this? Are you seeing that? Hey, are you using text analytics? Are you using this? What tools are you using, or what algorithms are you using? So this is really one of the things that started it all, and the what algorithms question. And so we thought, hey, we can start, instead of just having those hallway conversations, let's actually ask a bunch of data science professionals, what are they using? And it's really been interesting to see that over these 10 surveys and 15 years, we've seen regression, decision trees, and cluster analysis be right there at the top. Time series right behind it, as the tools the algorithms, I should say, that are used by the majority of data science professionals to get their jobs done. It's always been that cluster. A few times they might switch order, but they're always in the top group. But then it's also interesting to see where some of the other ones have risen up. So 2007, we didn't have ensemble models because there's no easy way of doing those with the software available at the time. Now everybody's using ensemble models, and you see that ranked pretty highly. We also see deep learning and neural nets, also and text mining, all sort of rising up and being used by more people as the tools to enable those to be used become more easily available and better tools. Tim,
Yeah,
do you have
I'll be
any?
interested. I was going to say, I'd be interested to see if any of the large language models make it here in the next survey. I don't know. It's interesting stuff.
Yeah, no, that's a good point. And so, yeah, we'll see if they do. The other thing just to point out on the algorithms before we leave this page is that people don't use just one. You know, the average respondent reports using 7 different algorithms. So it's not just that, you know, hey, I use this one and that gets everything done for me. The average person is using a variety, which is great to see. So that has been consistently large and going up over the years too, as it's gotten easier to do this. If you were hand coding your neural net, well, you don't have time to be doing hand coding of 5 other ones too. But now that we have tools to do these, it makes it easier. Okay, next slide, please. So focusing again on a little bit deeper on deep learning, one of the reasons for doing this, and all these slides are going to be available for all the participants later, is we wanted to make sure that when new people coming into the field are, you know, wanting to get started, well, you know, knowing that regression decision trees and cluster analysis are good places to get started if you want to get the algorithms that are going to be most important to get a bunch of work done. Same with deep learning. We want to say, well, hey, what things are people using in deep learning? The convoluted neural networks, the recurrent neural networks, and transformers are the top 3 neural network algorithms that people are using. So if you're just getting started, that's a good place to start. And it was also interesting to see that since deep learning is relatively new, we thought there's a possibility that's just being embraced by newer people coming into the field, and that the old people who are already always using their other algorithms and not deep learning, we thought, well, are those people adopting this and using it, or is it only the new people? And what we found was actually people who have years of experience working in data science are really embracing these deep learning algorithms. So you can see there in the bar chart on the left, people who've been working there for over 10 years in the data science field are actually just as likely, maybe even slightly more likely, to be using deep learning than people who are new in the field. So that's interesting to see. It's really being embraced. Next slide. Okay. People always, of course, want to know, hey, what software are people using? Again, data science professionals are typically using multiple tools, on average about 5 tools. Some people are using far more than that. But Python adoption has really increased. We saw this back, 5-10 years ago. We were seeing a rapid increase of use of R. Now we've seen the sort of same rapid sort of increase in the use of Python being used by more and more people. And this is not just in one setting, it's the corporate people, it's the consultants, it's the academics too. In the academics, there's still more people using R than Python, but Python has really rapidly risen up in all these places. R is being used more by academics than others. As you can see, it is the top thing there, but not the top thing. It's further down the list. Of course, everyone says they use Excel and and other things and SQL and stuff like that. But then when we ask people, if you go to the next slide, which the one package that they're using most as your primary tool, you see things like Excel and SQL drop out, and you see that more people are using R and Python, and KNIME and a variety of other packages as well. Now, let me orient people to this slide. And again, all the slides are going to be available for everyone to take home and look at in more detail. But just to orient you, we wanted to give you some comparative information. So the bottom 3 pies are from 3 years ago. That's our 2020 survey, and we wanted to show you how things are changing over time. The top 3 are the newest results from this year's survey. So you can see there in the corporate setting, if you look at the left too, that there's been somewhat of an increase in the use of Python as if you say, what's your one primary tool, and a bit of it among the corporate people, a little bit of a decrease in the use of R as people identifying as the primary tool. And there's a smattering of others. Same sort of pattern with consultants. We see slightly more people on the Python side, slightly fewer people saying R is their primary tool, and a mix of other people using other tools as well. R remains strong with the academics as well as Python too.
Karl, it may be interesting as more and more work gets done in the cloud, and we have cloud platforms that incorporate various components of these things, whether you're running Python or R or SQL scripts. Indeed, if you're using one of these new data science cloud tools, you're using all of them, kind of similar to the way that we're seeing people use multiple algorithms. So I'll be interested to see how this evolves over time, and how we describe a tool when it's like, well, I'm using a suite of tools, that somebody else put.
No, that's great. Yeah, no, that's a great point too, and a good reminder for me. I was just jotting that down. That and we want to hear other people's ideas of hey, what other questions or what other topics should we focus on in future surveys? Because we'll be doing another one in 2025. And I made a note there about the cloud stuff. We have asked about cloud. Where are you doing your analytics? Is it is it on a big server? Is it on that's standalone in your office? Is it cloud? Is it on your laptop? Where are you doing it? But we haven't asked that question in a couple of years, and I bet we would be seeing changes, and especially thinking about the tools in conjunction with the where. So yeah, good. Next slide, please. All right. So hey, it's nice to say that job satisfaction is high. We thought it was as high as it could go, but then it went even higher. So this is just extremely good. People are happy with their jobs as data science professionals. So it's, if we look at that there, we're looking at sort of like 88% of the people in corporate settings saying that they're satisfied or very satisfied. That's huge. That's like way higher than we would ever expect in most other fields. I don't have any immediate comparison points that are in data collected in the same exact way, but this is extremely high. We did not expect that it would be this high. We thought it was good in 2017, and look where it's gone. It's definitely gone up, in this, especially in this corporate setting, and it's going up in some of the other settings too. The consultants, the academics, large proportion there. With the dark green at the bottom saying that they're very satisfied, and very few people at the top of these saying that they're unsatisfied, or dissatisfied. So, this is just really good. People are happy. Next slide. And one of the questions that has been coming up, especially thinking about the pandemic with the big growth of data science, are people finding difficulty, are people having difficulty finding qualified data science staff? We were a little concerned about that, but actually, no, we're doing okay. There are some people who are concerned about it, but it does seem that it's not like everybody is very concerned. There's 18% of the people here saying they're very concerned. 22% additionally are moderately concerned, but there's a large enough proportion here of saying, hey, they're not particularly worried. But we did ask too, what are people doing to, if they are concerned, to address any shortages in finding qualified staff? And it was interesting there to see the partnerships that companies are forging with academic institutions or conducting internal training. So seeing education is the way, one of the ways around this. Of course, they're trying to more widely publicize their jobs and other stuff. But overall, it's the partnering to get internships, work experience, and do trainings inside their company to grow their staff and grow their skills.
I'm particularly encouraged to see the high number on conducting internal training, because I think there are a lot of people who can definitely, do this work. They just need to acquire some of the language and some some of the thinking patterns. It's not beyond, there's sometimes a misconception, or, people are a little bit intimidated by the topic. And so they back away from it when, quite frankly, this is no harder than, tuning a database or a lot of the other things that are challenging that people do every day.
Right. And the other nice thing with that is that by training internal people, those internal people might already have good institutional knowledge about the data, about the business topics and stuff. So if we can get those people trained, it's not like you're now unleashing a data scientist onto something where they don't know anything about the data and the quality and the database and the business purposes that are around it. So in training internal people is wonderful. I agree. Next slide, please. So then measuring success of analytic projects was something else we wanted to inquire about. We have asked about this in a few years back, but we wanted to get more information on it. So first of all, how often does your company measure the success of analytic projects? Well, on the left-hand side there, we've seen this before, but we're still seeing it now. There's not been great increases in the proportion of people that actually are measuring the success of their projects. So if you ask them, how often do they do it? They're not saying always. You get to most of the time, but that we're still at less than half of the people saying that they always or most of the time measure it, which means that a lot of the time you're doing an analytic project and you're not trying to measure the success of it. Well, that's not a good recipe, I don't think, for doing data science. You want to be measuring the success of your projects. Now, when people are measuring the success of the projects, I like seeing what I see on the right side. So we asked about this a couple ways and say, how do people typically measure the success of the analytic projects? And we had people select off any that apply. And then we asked a new question too to say, hey, what is the single most important success metric at your company for analytic projects? So number one, in terms of what people do is, sort of the model-based things, algorithm-based things, like what's the R squared or the area under the curve? How's the model performing sort of more technically? Okay, well, that's an easy thing to do when you're doing your models and you're picking which model you're going to use. That's going to be something that's easily and should be easily available. That should be 100%. I'm not sure why it's only 56%. 100% of people should be doing that. But it's nice to see that is the number one thing. But it's also nice seeing that when we look at that list and we ask people what's the single most important one, the most important things are actually more business focused metrics. So it's great to see that the return on investment, revenue growth, those are two of the top five. Also, improved efficiency or producing insights. So really 4 out of the top 5 in terms of most important are actually business focused metrics, and that's great. I want to see, making sure that the data science gets deployed, it gets used. We're measuring success, not just technically. Does the model, technically look okay, but is it meeting the business needs that it was designed to build?
Some of that may be. Sorry to interrupt, Karl. Some of that may be because they're running unsupervised models that really don't have a sense of accuracy or performance or whatnot if they're doing a lot of clustering. But I agree, it's an interesting finding. So
yeah. So all right, so that's that. Let's quickly go to the next slide. Okay. So we also asked just an open-ended question near the end saying, hey, upcoming impactful changes in data science, what will be the most impactful changes in the next few years? And we had over 100 people giving us their ideas, sometimes just a few words, sometimes, long paragraphs. And it was great to see. And no surprise, 30% of the people in one way or another mentioned ChatGPT and the large language models, sort of like Tim was suggesting. Are we going to be seeing that in upcoming surveys? And several people highlighted not just that, hey, these things can be done, you can use these large language models, But several people had creative ways that they were articulating, saying that they think that in the coming years, the large language models will actually help with data preparation, handling messy and dirty data, maybe some feature engineering. So utilizing those large language models, not just as a model, but also as a model to help our existing data science processes get better. So that was interesting to see. Other people certainly talked about some regulatory things, some data privacy things, the need to better explain black box models so that people understand what's going on, which of course for the large language models is particularly an issue as well. So there are some challenges that people are pointing out, but a lot of optimism is also what we heard.
Yeah.
Next slide, please.
Yeah.
Oh, and what, Tim, please add.
No, I was just going to mention that this is also interesting from an Oracle perspective. Just that the automated insight generation was mentioned. That's a
Right.
major feature in Oracle Analytics Cloud, for instance. And so they're boiling in, kind of this machine learning capability throughout the product. So into the data preparation step, into building dashboards in which visualizations are used, into actually producing one-click forecasts and things like that. So there's or even figuring out what do I make of this data set, automatically generating what does the data tell us in terms of a normal suite of algorithms we're going to run, and then peruse those results on.
Yeah, totally agree. And also on the bottom left too, harnessing inputs from multiple data sources, not just the traditional data science of you have one data table and you're working on it and you have to pull everything into that one data table. But you're right, the Oracle abilities to then leverage a bunch of these different data sources at different levels of granularity is wonderful.
Yeah.
Okay, next slide, please. Okay, so we've got all these great skills, we're satisfied, we're liking our work, we're excited about the impact. So let's talk about how we're deploying our models and the impact we're having. Next slide. Okay, so what proportion of models are deployed into production? Uh-oh. This is now we go, wait. Maybe we saw a little bit of precursor of this when we were talking about how often people are measuring the success of their models, but they're also having difficulty getting them deployed. Only 32% of the people said that their models are deployed the majority of the time. So, wow, like why only 32% of the time? You went all through the big process of building your data science model, you had this predictive model, it's ready to go, and only 32% of the people say that they're getting them deployed. What are you doing with their models if you're not deploying them? What's happening? What are the barriers? What's going on? And also, let me point out that we asked about this, and this is, again, some of the input from Eric. We asked about this in a couple of different ways. So we asked, well, okay, there's some existing initiatives. That's where you already have a model that's in production. And now you're just coming up with a new model, and you're going to swap in this new model that you just built into an already existing workflow, an already deployed model. You're going to just take that one out. You're going to put your new model in. Well, you should have close to 100% deployment there, right? Because it's like you already have a whole business process with a model in it. You're just now putting a new one in. But no, those existing initiative scenarios there, still surprisingly low proportion of people are saying that their models get deployed. Now, it doesn't surprise us if you have some revolutionary new initiative, where, it's like you've never used modeling at all in that situation. It's a totally new process. Like you've never done fraud detection before. Now you're building a fraud detection model. It's like, okay, in those situations where you've never done fraud detection, I understand that there might be additional barriers to getting things deployed. But the top one, their existing initiatives, there's definitely something wrong here that we're not getting those deployed all the time. So let's dig into that a little bit more. Can we go to the next slide? So, well, first of all, we tried digging around thinking, well, maybe the experienced data science professionals are getting their models deployed all the time. Or maybe at the big companies, or maybe at the small companies. No, we dug around a bunch of different ways, and deployment's bad everywhere. No matter how experienced the person is, no matter what type of algorithms they're using, what types of tools they're using, it's just bad everywhere. We could squint and maybe find a couple places where, actually the people using deep learning maybe have a slightly higher deployment rate, or the people who are actually newer in data science, who have a slightly higher deployment than people who've been around longer, maybe working in more challenging areas, or I don't know. Maybe the new people haven't been disillusioned yet. I don't know. But it's basically, it's just bad everywhere. So next slide. We're going to try to dig into this. Why is it bad? And what can we do to improve it? Next slide. So this is where Tim and I were talking about, and he started to remind me of Calvin Moore's law. So Tim, I'm going to pass it to you here, and I paraphrase what you told me on the phone.
Yeah, well, thanks. That's interesting. I didn't expect a quote from me, but no, the point is this quote from Calvin Moore's goes back to the 50s. So at the dawn of the age of, if you will, corporate computing and building information processing systems, it was recognized that an information retrieval system, database, will tend not to be used whenever it is more painful or troublesome for a customer to have information than for him not to have it. I think that's fascinating, that this is just a human dynamic, and that a human challenge in terms of how do we actually change and improve, especially when we have multiple people involved in large organizations. And it just seems like, yeah, will always be, this will be the area that we have to do the hardest work. The math is.
I think it's right. No, I think that's great. Saying, hey, we're satisfied and we're happy with all the tools and the whiz bang stuff we're doing. We like our algorithms. We're happy with our jobs, but we're not actually getting that final mile to get our models actually deployed and being used by the business. And there's some resistance there. So go to the next slide, please. Now, this is one of the places where I'll give Eric's new book that he's coming out with in February a plug. That he's been also seeing this in a lot of the case studies and a lot of the conference people that he talks to in his machine learning week. And so that's really a focus of his new book, to say, well, it is that human process, as Tim was saying. And where does that human process need to start? If we want to increase deployment, we actually need to start at the beginning of the project. We can't just build our models and then think about the deployment at the end. We need planning up front. We need well-defined objectives before a project starts at the beginning. And you can see here, when we ask people that, well, how often are your project objectives or research problems well-defined before you get started? Not as much as we'd want here. We'd want to see this chart being all green, but only 34% of data scientists say that their objectives are usually well-defined before they get started. So, okay, well, that's where we need to focus. We need to Eric's words, we need to get the business people involved in the data science process enough and better understanding some of the data science stuff. They need to step up and understand data science more, but the data scientists need to step up and also understand the business and focus and push the business to get the business involved and understand what business success metrics and possible deployment situations. So you know that when you're building a model, that the data is going to be available at the time of deployment. You can't build a model and then learn later, oh wait, that model is impossible to deploy because that data that you need for model prediction isn't going to be available at the time that the decision making needs to be made and the model needs to be deployed. You should determine all of that stuff way up front before you get started building the model, so that you only use data that would be available at the time of deployment, just as a simple example. So
Karl,
earlier planning at the beginning.
yeah. You know what this reminds me of? We're just listening to you talk and looking at this, is the crisp DM, process. And the fact that that starts with business understanding and developing good problem statements and then data understanding. Those are the first two steps. And maybe we
Right.
need
But
to go back.
we need to go back and do more of that, but we also need to make sure we all have buy-in, not just, hey, the data science team agrees to this, or just the business side agrees, but we have to make sure we get both sides of that,
Right.
understanding the business issue and making sure that the analytic issue is aligned to that business issue.
Yeah. There are
Next slide.
Yeah, go ahead.
No,
Yeah.
go ahead, Tim. Keep talking, but we can go to the next slide in the meantime.
I think that there are times when the business side thinks that it's just a very procedural process. I mean, it's just very mechanical, like, well, data scientists, go do your work, and they don't understand that we need their involvement and input and insight and preferences in terms of those trade-offs as to, how are we going to actually implement this and make better business decisions. This isn't, building something and then it's done. It is the
Right.
back and forth that's the real work.
Yeah, and so the left side of this here, when talking about the deployment issues here, I think emphasizes Tim's point. We need, it's the human side of this, we need to have the managers or decision makers in the organization stepping up to better understand the data science, but it also means that we need to be informing them. If you are a data scientist, you can't just, you have to inform your business people that you're working with. You can't just say, oh, I'll take care of the data science, and just throw it over to me and I'll take care of things. No, you need the managers and decision makers to be informed enough about what you're doing so that they can make informed decisions about the deployments of models later. Because right now, we're only seeing about half of respondents saying most or always to this, are decision makers knowledgeable enough to make good, well-informed decisions when it comes to deployment. So we need to better inform those business decision makers so that this chart is more green. If this chart is more green, we would have larger deployment if they're better informed at the beginning about what's going to be needed for deployment. How are we going to deploy it? How are we going to use this model in the business process? If we know, this is going to help. We also asked a new question saying, what are the main impediments to model being deployed in your organization? The top things there were also things about decision makers being unwilling. So that's going more to Tim's point about, hey, this is hard, or lack of planning, lack of understanding. There are still some issues about availability of data, but most of these here are, addressable by the people problems. Who's going to steward it through? Mostly it's not technical or data things, it's more the people things. Yeah.
We have a comment in the chat from Dan that there's always an issue of trust with people who are asked to be involved from the business side. Do I trust this analysis? And especially given some of the conversations that are happening across the broader society, this is something I think we all have to recognize and find the right patience and to bring people along from wherever they're starting, and understand that there is this issue of trust, and we need to reinforce and build the approach and the strategy of saying we are working hard to let the data reveal itself to us through these processes, but we're not trying to impose our views on the data. And that's happened a lot, unfortunately.
It does. All right, if you go to the last slide for us, I guess the second to last slide, the primary reasons for non-deployment, just we sort of explored that a little bit more, even with an open end. thing. And so we had 75 people, who this was they wrote sometimes quite a bit telling us back, what was going on. So we're seeing things like, well, it didn't get deployed because it required too many different teams and not sufficient resources dedicated to get across that finish line. Or the key contacts aren't empowered to act and deploy it. Or just change doesn't come easy. So it's, again, it wasn't data things we were seeing. It was lack of ownership of business leaders or lack of organizational confidence to move forward with it. Or being ready for the business change process. If you now have a model and it's going to require you to do something different in your business. Well, the business change aspect of it, the people aspect of it, is more what's the primary reasons for things not getting deployed.
Yeah. This is really interesting, and one of the things that I'm very excited to get a hold of Eric's new book, but I'm wondering if there are some kind of leading practices or best practices that we could blame, in other words, use with clients to say, well, here's the list of questions that we're supposed to use, and when we describe this, so there always seems to be a little bit of a power dynamic as to who's in charge or who's leading. And the executives often want to, serve that role, but they may not feel comfortable in leading this kind of stuff because it is new, or they,
Right.
there's a lot there. Whereas if we had
Right.
something from the outside, if you will, to say, hey, here's what the best people in the industry are recommending as the questions or the outline that we should follow, then it's my opinion, your opinion, or somebody else's, some vice president's opinion,
Yeah. Well, I think it's important to, in terms of those best practices, one thing that I would sort of stress more than anything else is at the beginning of that project, how are we going to measure whether this is successful, and and talk up front about what is the business process going to be that gets changed. How are we going to change? We're going to have a model. How is the model going to get used? How is your business going to change when you have a model inserted into that? So then we can then say, oh, it's going to change that way. So we can now measure the success here. But to know that something's going to need to get inserted and change, which means, people in the call center or people, on the front lines or the people in the marketing department are now going to have something different and new they're going to be utilizing. And so let's talk up front before you build the model about what is the business way that's going to get integrated into your business. And if you're not going to integrate into your business, don't build the model, or have the goal of the model to be maybe to provide insights and not trying to build a deployable model, now focused on generating business insights, which might be something you could use as a precursor, generate some business insights as to key trends or key things going on. And then with that information, have the next step be, now, what could we build a model that would help improve things, and where can it focus, what data can it use, and gradually get some buy-in so you have deployment.
Yeah, there's a request here for Eric Siegel's contact, or maybe just the Predictive Analytics Week or the magazine Predictive Analytics World. We could post a link, or people could just refer back to that slide to find out.
That's certainly a good point. So Eric's full name is Eric Siegel, and you can if you just go straight on Amazon, you'll see immediately that he has a very popular data science book there, which I highly recommend. And the new one should be coming out in February. That's going to focus on the deployment issues.
It's IEGEL.
I would have to go back to the first slide to see to make sure I get that correct. Thank you for the person who's flipping back. And next one. Nope. Go forward, please. There it is.
I had it right.
SIE, yes. So yeah, just anybody go to Amazon. I definitely recommend his first book. I think it's now in a second edition. And not just because I did some editing and contributed some cases, it's a good book.
Yeah.
All right, so definitely wanted to make sure we save some time for questions and any other comments that people have for discussion. So let's open that back up. And if anybody has any additional questions, they can always contact me. My contact information is on the screen. And again, these slides are available for everybody. And I think that I'd be happy to send those out, or any who the organizers here can send those out to the participants. That's great. And
it'd be great it'd be great to use the survey results at the beginning of a project also to reinforce, hey, here's what, here's what's suggested. And, we don't want to fall into the red area of the deployment.
Right. Yeah. To recognize that, hey, this is a problem that lots of people have, and let's do what we can to try to avoid this problem.
Right.
Don't fall into this trap.
I'm thinking,
again, I don't want to be all negative about things either. I mean, there's lots of good data science out there. We've all done some good data science. I've also occasionally been frustrated where, I have build models and the clients say, thank you very much. And I realize that they're not going to deploy it. So it's like, I'm not immune to this. Most of my projects do get deployed, but I definitely have had frustrations where some don't. So I wish I was in the 100% category. I'm not.
It's interesting. One of our more recent engagements, they're so anxious to deploy. We wanted to make some modeling. We wanted to make some improvements actually with the data and what we were collecting, and then think through carefully how are we going to deploy this, and have we done enough? And because the ROI would have been there to do more work, and they were just like, no, thank you, we're gonna, and you're like, no, stop, wait.
So they deploy too fast, maybe, but okay.
Wait,
so people are all over the place.
Right. And I think this is, kind of the check the box off, check the box on the list kind of thinking. And, we have a model. And it's like, no, the part of the process of doing, predictive analytics is figuring out then what other data can we use to improve this, and how are we, conceptualizing and thinking back to your point, Karl, about, what is the major purpose or problem we're trying to address here, and kind of tying it back, as opposed to, I have a model, now I go deploy it.
I'll remind people that you can put questions in the Q&A. Tim, there's one in there now that you can read, but go ahead and put your questions in there. And while I have the floor, I'll just thank Tim and Karl for presenting on this. I think this is a great addition to our library, and I'll turn it back over to you to handle the questions.
Super. And thank you, Dan. If you can be the one to send out the slides to people, that would be great.
Yeah, we'll have that on our website, Karl, at AnDOUC/TechCasts. We'll make the PDF available for people for download there. I'll also tell people, if you have colleagues that missed this, we'll make the recording available off of there and off of our YouTube channel. So AnDOUC/TechCasts, it'll appear there in a few days. It takes us a little bit to upload to YouTube, so it'll be there soon. Go ahead.
We have a good question about overfitting, Karl, if you have some thoughts there.
No, I do see that question about the overfitting, and from John there. And John, it might be better to take this one offline. So if you want to contact me, we can talk about overfitting. But in general, there's a lot of different types of settings in the different individual different algorithms. But also trying to run your to check for overfitting. It's like, is also important to know when you're overfitting and when you're not overfitting your model. And for those who aren't in the depth of data science model building, overfitting is a problem when you often have many possible predictors and maybe not enough cases, and your model is just churning, and it's going to fit the noise maybe and not fit, just the main patterns. So when you try to apply it to a new data set, it won't do as well. So the main thing there is to make sure that you are at least monitoring whether you are having overfit by making sure that you have several different partitions of your data so that you can build your model on one modeling data set and then maybe have one or two additional randomly selected subsets of the data that you try running it on those. And if you see that the model you build on the modeling data set does not perform well in the holdout samples, then you probably do have overfit. And some ways you could to look to try to avoid that would be to look at some of the data features that are selected as your key predictors and do it in a couple different subsamples again. And if you see that age and income and whatever other data features you have are really important in one data subset, when you try building your model on subset number 2, you end up with a totally different set of predictors. Not good. Look to see which ones are common as key predictors across multiple data sets, and those are ones that are probably the more robust ones that will now work when you're now in deployment and you're putting this and applying the model to totally new data. You want to make sure that the ones that are consistent across other subsets are going to be now consistent and working in the future.
Yeah, couple other those great comments. Couple other things to keep in mind, particularly with neural nets. We don't get the transparency in those algorithms that we do through. We don't get summary statistics the same way. So you may want to try some other algorithms. I think Karl's idea of trying different samples of the data is excellent. The other thing and this is kind of a robustness check, you may want to, indeed look at how much of the model's quality is coming from how many of the parameters. And how much contribution do we have from across the width of the data set? We may want to indeed leave some things out and see what happens.
Yeah.
And that can also be another method to check for overfitting.
Right. Yeah, we always try when we're coming up with our models for deployment that we don't just throw all the data, all the variables in, and then just deploy that model. We'll try to see if we can reduce the number of key predictors down and still get the same good model results. Then we will go with a reduced model, because the other data features that are coming in are really just overfitting and are not adding additional predictive power of how it does in a holdout data set. So when we have the model developed here and we're testing it in a holdout data set, if we see that a model with 20 variables is performing just as good as that model with 40 variables, we'll go with the smaller model because it's going to be easier to deploy. It's not going to have as many problems and things that would break when you deploy it. So we're going to go with the minimal model that gets good results, not something with everything in the kitchen sink in it. And lastly, I know in the Q&A, people are also asking how to get started in a professional career in this space. I would say that, if you can get an internship, if you can get a starting job working in this space, try working in this space is a great way of getting going in your career. Look for jobs that need data science skills. There are a lot of jobs out there for data scientists, so there's good opportunities. If you're having trouble finding one of those, one way you can boost your credentials would be to take on some free projects or do something like compete in a Kaggle competition or something else where you could demonstrate and put on your resume that you've actually built models and done well. So if you could like get a sample data set from a Kaggle competition, participate in that, show that you get up on the leaderboard in some way, that, hey, you were able to build models and they performed well, then you can add that to your resume. It's an additional thing that if you don't have career on the job experience, that can be a good substitution.
Yeah, I would also say find organizations that are important to you and see if you can do, if they have data, see if they'll let you have it and just do some work for them. You know, I mean, you can think about your church, your school, your
Whatever, yeah.
your community you live in, and help them. You know, there are lots and lots of issues out there, lots of problems where we need, what's the forecast for next year or the next 5 years? Where we need,
Absolutely.
what is the biggest problem and what's contributing to it, because it's really hard, it's really complicated. We have all these things going on. How do we start to break it apart?
Right. Yeah. All right.
All right.
Any other questions before we go? Well, I appreciate everyone's time. Thank you for joining us today, and we will enjoy hearing any other feedback. Send me emails, and enjoy the rest of your day.